Hello, welcome to our channel Chemflix. Okay, so today we're going to discuss about another one interesting chapter of our 10th standard, that is chapter 2, that is acids and bases. So this is me, I'm Ravina Rafi. Okay, so before that, let me ask you some questions regarding to acids and bases. What are the characteristic properties of acids and bases, as you already studied in your previous chapter? Okay, previous class. Okay, in 9th grade you all studied about what is this acid and what is this base and so on. So here, this acid which is sour in taste, why we are having fruits like acid, apple, or any type of vegetables or grapes, or in tomatoes, you have this sour taste. Okay, so why this sour taste? This sour in taste is because of the acid which is present in that particular fruit. Okay, so in tomato it is malic acid which is present, or in tomato which is oxalic acid, which is the reason for this sour in taste. And in the case of apple it is malic acid, and in the case of grapes it is tartaric acid, and in the case of milk it is milk. Of course, milk also possesses some particular type of taste, and it's due to the lactic acid and so on. And the other one important characteristics of this acid is it conducts electricity when dissolved in water. Okay, when we are dissolving some acid in water, it conducts electricity. So what do you mean by electricity? Electricity is flow of charges or flow of electrons, can be called as electricity. And why these acids conduct electricity? Why you are dissolving in water? It is because this acid gets dissociated into its constituent ions, and these ions have a particular property of movement, and due to this movement they can conduct electricity. And the third characteristic is it turns blue litmus red. Okay, it turns blue litmus red. We can see in our coming slides. And next we're going to discuss about what are the sources of acids. Next we're going to discuss about what are the sources of acid. You can see here it is vinegar. It is commonly present in our all kitchens, and it is acetic acid. Actually, commonly it is acetic acid. Chemically it is acetic acid, but commonly it can be called as vinegar, which is used in our kitchen. Okay, and coming to this is lemon, which contains of citric acid, source of vitamin C. In this lemon it contains citric acid. And coming to this is tomatoes, and you can see here tomato contains oxalic acid, and this particular taste of this tomato is because of the oxalic acid present in it. And coming to this, it is grapes, green grapes or whatever it color, it contains tartaric acid. And another one is milk. You know, this milk which is white in color, it is due to the presence of casein, and it contains this acid, lactic acid. Another one is our ant. Okay, why we feel itchiness while an ant bites us? It's because of the acid which is present in ant, that is nothing but formic acid. Coming to this, as we already said, that is apple, it contains malic acid. And about bases. What is this base? This base, this base is bitter in taste, which conducts electricity when dissolved in water, same as acid, and it turns blue, red litmus blue, BB, okay, blue. And what are the bases? What are the common bases which you had seen in your daily life? Like paste, okay, and antacids like aluminum hydroxide or magnesium hydroxide, which neutralizes the excess acid in our stomach. And this is ammonium solution, which is used for rubber tapping. And this is a common soap, and also this is detergents. So these are common examples of bases, which is bitter in taste. While you are having some soap in your mouth, you feel some bitter taste, and while you are having some medicines, you feel bitter in taste. And it also conducts electricity when dissolved in water. And the one particular characteristic property of bases which turns red litmus blue. Okay, I will show you in your coming slides. Before that, I just want to introduce one more term, that is indicators. What do you mean by indicators? Indicators are the substances which show some color changes and indicate something. Okay, it indicates something. It indicates us something. So that is indicators, the term. So today in this slide we're going to our class or our textbook, NCERT textbook. It is page number 18. You can see an text question there, and the question is, you have been provided with 3 test tubes. Okay, test tube A, test tube B, test tube C. Okay, you've been provided with 3 test tubes. One of them contains distilled water and the other 2 contains an acidic solution and a basic solution. Okay, these 2 solutions are colorless. Of course, this water is also colorless. So 3 test tubes, and 3 test tubes carries acid, base and water. If you are given only red litmus paper, okay, only red litmus paper is given to you, how will you identify the contents of each test tube? How will you identify? So the correct answer is, we are going to see what is the correct answer. Before that, let me introduce you what is this litmus paper. So litmus paper is a paper which is made up of, you can make directly this litmus paper using some hibiscus flower. You're rubbing hibiscus flower over the paper, you will get a blue color. Okay, so that is blue litmus paper. And here you are provided with red litmus paper. This is actually this red litmus paper. And while you're dipping this red litmus paper to acid solution, okay, while you're dipping this red litmus paper to acid solution, acid red litmus paper retains its color, that is acid, it is red in color. And in base, what happens to the red litmus paper? It changes to the blue color. Okay, you can see the coordination here, acid red and base blue, this BB and this DD. Okay, you can see this coordination here. So the litmus paper, it turns red or pink in an acidic solution and it turns blue in a basic solution. So that is litmus paper. Okay. So what is the answer of this question? The answer of this question is, if the color of the red litmus does not change, then it is acid. If the color of the red litmus changes to blue, then it is a base. And if there is a slight change in the color of red litmus, then it is distilled water. Slight color, it is due to the wetness while you are dipping this litmus paper, red litmus paper in the waters. Okay, so acid-base indicators are the substances which indicate the presence of an acid or a base in a solution. So what is this acid-base indicators? They indicate the presence of an acid or base. They indicate the presence of an acid or base. Similarly, litmus paper we have taken. What is this litmus solution? It is a natural indicator. It is a purple dye extracted from lichens. And other one example are red cabbage and colored petals of petunia and turmeric. Okay, did you see this figure? This is, you can see, why you are adding bleach to the juice of red cabbage, you will get yellow color. Why you are adding baking powder, you will get this ultra green color. And why you are adding some sanitizer, you will get this color. And sugar solution, you will get this color. Water, of course, the light color of purple color of red cabbage. Sprite, why you are adding Sprite, why you are adding vinegar, why you are adding lemon juice. You can see a variety of colors here. It is from the red cabbage juice. Okay, from this you will get an idea that these indicators, they indicate something. Okay, and coming to the olfactory indicators. What do you mean by this olfactory indicators? Olfactory indicators, they show odor changes in acidic or basic media. Okay, they show odor changes, which means we can analyze whether it is an acid or a base through smell. Example, onion and clove. Some of the acid-base indicators are blue litmus solution, red litmus solution, turmeric, methyl orange, phenolphthalein. And phenolphthalein is actually colorless solution. Okay, methyl orange, as the name implies, it's a red-orange color solution. And the color change with acid, it is red, and color change with base, the methyl orange shows yellow color. And in the case of phenolphthalein, the color change with acid is, there is no change as it is colorless, and when base, phenolphthalein changes its color to pink. You can see here difference in the color. This is a methyl orange. pH 3, it means it is acid, and pH 11, it means it is base. Okay, in base or in alkalis, the methyl orange changes its color to yellow, and in the case of phenolphthalein, it changes from, or it gradually develops a pink color. You can see here from 8 to 11, you can see a gradual development of intensity, increase in the intensity of the pink color from 8 to 11. When it is in 11, okay, or when the pH is 11, you can see here it's a dark pink color. Okay, and coming to the red litmus solution, red D, so which means in acid solution there is no change, and blue litmus solution B, in basic solution there is no change. Okay, I think you all got an idea about this acid base indicators and all. And next you're going to conduct an experiment, that is activity 2.1 of your class of your NCERT textbook, and it is about you need to take some samples of hydrochloric acid, that is HCl, sulfuric acid, that is H2SO4, nitric acid, that is HNO3, acetic acid, that is CH3COOH, sodium hydroxide, that is NaOH, calcium hydroxide, that is CaOH twice, potassium hydroxide, that is KOH, magnesium hydroxide, that is MgOH twice, and ammonium hydroxide, that is NH4OH. If you don't know how to write or how to write the chemical formula, please go and watch this video. Okay, you can see somewhere here, over here, you can see the link of that particular video. Okay, and the task is put a drop of each of the above solution on a watch glass and test with a drop of the following indicators as shown in the table 2.1. Okay, there is table 2.1 in your textbook. I will show you. And what change in color did you observe with red litmus, blue litmus, phenolphthalein and methyl orange solution? That you need to record. Okay, and the thing is, when you add HCl solution, when you take HCl solution in the petri dish or watch glass and you are adding red litmus solution, HCl is an acid, so no change for the red color, and the blue litmus solution changes its color to the red, and phenolphthalein, as we already said, that colorless in acidic solution, and methyl orange shows red color in basic solution, sorry, acidic solution. Okay, and coming to this is another one, that is sodium hydroxide. It is a base, it's an example for base, that's why BB, base. So red litmus changes to blue, and BB, so blue litmus no change, and for phenolphthalein it changes its color to pink, which means, as we already seen here, the phenolphthalein, when the pH increases and reaches 11, you can see here the intensity of pink color that gradually develops. That means in basic solution, indicator phenolphthalein shows pink color, and methyl orange, it shows yellow color. Okay, and in the case of ammonium hydroxide, that is NH4OH, the phenolphthalein solution, it is pink and it becomes colorless after some times. And of course, in methyl orange solution, it also colorless after some times. At first it develops yellow color, and after some times it becomes colorless. Okay, and you have there one more activity related to the olfactor indicator. Okay, and coming to the next activity, that is how do acids and metals react with bases metals. Okay, this activity where about 5 ml of dilute sulfuric acid you are going to add to a zinc granules which is taken in a test tube. And what do you observe on the surface of the zinc granules? Past the gas being evolved through the soap solution. Why are bubbles formed in the soap solution? Take a burning candle near a gas-filled bubble. What do you observe? Repeat this activity with some more acids like hydrochloric acid, nitric acid, acetic acid, etc. Add the observation, and all the cases the same or different. Let's go and watch the video. So this is the experiment to prove that when acids react with metal, hydrogen gas is evolved. Okay, you can see here the materials required for conducting this experiment is a clamp, a test tube, then a rubber cork, then soap solution, zinc metal granules, and hydrochloric acid. Okay, of course this is the delivery tube. I forgot the name. Okay. So these are the things which needed for conducting that particular experiment. So take about 10 ml of dilute hydrochloric acid in a test tube. Here you can see 10 ml of hydrochloric acid you are taking with the help of a beaker. And add a few zinc granules to it. This is the zinc granules, okay. From this battery, inside the battery the metal is zinc granules. If you want to see this, okay, look at this reaction. What is happening here? Bubbles. You can see so many bubbles here. And close the test tube with one holed rubber cork containing delivery tube. So this is the delivery tube, and we are collecting this gas and passing into the soap solution, okay, which is taken in a beaker. Okay, you can see here bubbles are forming, gas filled bubbles are formed in the soap solution. You can see here. And now we're going to conduct what is exactly these bubbles contain. Okay, here you can see this claws of motion. Okay, so this is zinc granules. You can see the reaction happening here, and the bubbles are, and these bubbles which contain in the gas is passed to the soap solution. Okay, when we keep a burning splint near hydrogen, splint should extinguish with pop sound. So this is exactly what is hydrogen, and we are going to test the hydrogen gas, presence of hydrogen gas here. So this is the pop sound and gas explodes. Okay, I'm going to show a candle near this bubble containing hydrogen gas. The candle burn off with a pop sound. What exactly the reaction is? 2HCl plus Zn gives ZnCl2, that is a salt, and this hydrogen gas, it gets evolved. And if we repeat this above experiment by using any acid like sulfuric acid, nitric acid, any acid, we get hydrogen gas along with the salt. Okay, you can see here this is the reaction when we using sulfuric acid, H2SO4. When you react with the zinc, you will get a single displacement reaction, that is ZnSO4 plus H2. And in the same way, when you are reacting with nitric acid HNO3, you will get ZnNO3 twice. Why this NO3 twice? Please go and watch that previous video about how to write a chemical equation, chemical formula. Okay, and H2 gas gets evolved. Okay, so you all watched the video, I think. Okay, this video is, I collected this video from the YouTube itself, and if you want to see any other videos like this, you can go and search in the YouTube. There are so many videos in the YouTube. Okay, so this is a pictorial representation about what we conduct now. What we just had now, that is the pictorial representation. It is in your textbook. Okay, so this gas, soap bubble filled with the hydrogen gas, it gets burned off with a pop sound while you are introducing a candle near these hydrogen gases. Okay, so what is the inference, or what it happens actually? It's that is zinc when react with the dilute hydrochloric acid, you will get a salt along with this hydrogen gas, and the inference are hydrogen gas is formed when an acid reacts with a metal. Whenever a metal reacts with acid, hydrogen gas will be formed. And the second inference is, on passing hydrogen gas evolved through a soap solution, bubbles are formed, and these bubbles contain hydrogen gases. Okay, and third inference is, a burning candle near gas filled bubbles causes a pop sound, indicates the presence of hydrogen gases. Okay, so you all have an idea about what we have done in this activity 2.3, and if you have any doubts regarding this chapter and in this video, you can ask me. Okay, you can ask me through the comment section, and